In this video, we're going to try to walk through piecewise limits and find out if we do have limits at each one of these piecewise functions. So as you can see, we have 1 over x plus 2, and it has a restriction if x is less than negative 2. For f of x, x squared minus 5, and then as you can see, the restrictions and so on. What we're going to do is we're going to take a look at these individually. And as I was taught, it's best to go ahead and define each one of these as an individual function that we're going to work with. So we'll have function 1, function 2, and function 3. So what we're trying to do is figure out if there is a limit. And the best way to do that is to just start with a number line, such as an x-axis only. So we'll start with a number line, and we're going to put down the numbers that correlate to each one of these functions that are important here. So really what we're looking at is function 1 and function 3 as the least and greatest in the function itself. So for function 1, x is less than negative 2. So negative 2 is going to be our wall. We're going to put a negative 2 here. Then we can jump down to function 3 in this one. It isn't exactly continuous, but we do have a jump from function 1 where x is less than negative 2, then x is greater than negative 2. As we can see, neither one of those conditions allow a negative 2 precisely, but we might have a hole there, or maybe it's an asymptote. We're not sure at this point. Then we go up to 3, including 3, and then x greater than 3. So it looks like we have 3 as a designated point. That's our greatest value there that's given. So we can put a 3 here. Next, what we want to do is just simply divide up this line segment, this x-axis. And what we're going to do is we're going to say, as we approach 2 from the left, what function would we be using? So function 1 says that for all values less than negative 2, well, less than negative 2 this way, less than negative 2 would be negative 3, negative 4. That means if we're using that function, 1 over x plus 2, that tells us that if we go the opposite direction, if we go towards negative 2, but never reaching negative 2, we're actually using function 1. So let's just go ahead and put function 1 is going to be as we approach negative 2 from the left. So in the middle, between negative 2, as we're approaching negative 2 from the right side, and we're approaching positive 3 from the left side, what function of x, what input x, has those numbers with which we can use based on our restrictions that we can see. And what I see here is that x is between negative 2 and 3 for function 2. So we're going to put function 2 here in the middle. And then we're going to have function 3, the only one remaining. And as you can see, that it's all values greater than 3. So as we're approaching 3 from the right side, that will be function 3. And the reason that we're doing this is so that we can easily refer to this number line and see what functions that we're going to be using when approaching those values to find our limit, if there's a limit that exists. So let's begin with the first one. And what we'll say is that we'll have, as the limit approaches, as x approaches negative 2, and then this big negative sign means from the left side. Well, now we need to put a function in there. We need to figure out, well, what do we throw in there? So as we approach negative 2 from the left, we have this function, function 1, we said, is going to be used for finding the possible limit as we approach negative 2 from the left. So function 1 is 1 over x plus 2. So we have 1 divided by x plus 2. So this is how we're using the one-sided limits to see if they're equal. So the next one is going to be the limit of x as it approaches -2 from the right. So from the right side, moving towards -2, we're using function 2, and function 2 states that x squared minus 5 will give our result. And then because we're moving towards -2 from the left and from the right, we're going to call this the limit as x approaches -2 from the left and the right for f of x. Remember, that's what our actual function is. So we're going to try to solve that limit. And then for the next number or next value for x input of 3, we will say that as the limit of x approaches 3 from the left, well, from the left, as we approach 3, we're still using function 2. So function 2 again is x squared minus 5. And then we have a limit for x as we approach from the right, as we approach 3 from the right. Well, approaching 3 from the right side, we've designated that as function 3, which is x plus 13. And actually, apologize, that is the square root, to make this more fun, of x plus 13. And finally, we would say, because we are approaching 3 from the left and the right, we can designate that as the limit of x as it approaches 3 for f of x. So we're trying to find out if our function as we approach -2 and as we approach +3 from the left and the right, if it has a limit. So we'll start on the right side. It is a little bit easier. And on the right side, let's see if I can scroll this down. We don't need the rest of this anymore. What we have just done is allowed us to start establishing whether limits exist or not. So we can scroll down here and give a little more room. And I will use this graph in a minute. And plenty of graphs, lots of graphs. All right, so on the right side, because we have a polynomial, and as we've discussed in previous sections, anytime that you have a polynomial, you can take the value that x is approaching and plug that into the polynomial to find a limit. So as x approaches 3 from the left side, we'll take 3 and we'll go ahead and input that. So 3 squared is 9. 9 minus 5 is going to give us 4. Again, we have another, let's see here. We do not have another polynomial. We actually have a square root of x plus 13. So we also know that you would take x plus 13 and say, okay, it's got to be greater than or equal to 0. And what number would make that, a negative, basically? Well, we're approaching 3. We're not concerned with any other numbers. So in this case, 3 is not going to make it negative. So we're okay. We can just go ahead and plug that in. So 3 plus 13 is 16. The square root of 16 is 4. And because we have equal values such that 4 is equal to 4, they're both positive, they're both the same value, we can say that the limit of x as it approaches 3 is going to be 4. So this does have a limit, and that limit is 4. So let's take a look at the other one. The limit of x as it approaches -2 from the right is going to be a little bit easier for us to solve first, and then we'll work on the other one, 1 over x plus 2. So In this case, we're going to say that this is a polynomial, x squared minus 5. We'll go ahead and plug our -2 value in for x. So we have -2 squared is going to give us a positive 4. 4 minus 5 is going to leave us with -1. So now let's look at 1 over x plus 2. So 1 over x plus 2. The only value we know that we cannot have would be -2, and that's exactly what we're trying to approach. So our limit as x approaches -2 would give us division by 0. Now we don't end up with 0 divided by 0, which tells us that there's a whole, but rather we end up with a division of 1 divided by 0. So if we did that, we'd end up with 1 over 0. And that tells us that anytime we have a 0 in the denominator, we're going to end up with an asymptote. If it was 0 over 0, again, remember that that means that there is a whole and that something can be factored out of the numerator and denominator and reduced to 1. So we will not be able to do that in this case. So the only other thing that we can do, that we know we can do, is to find out using the sign analysis test if we, for this first one, as we're approaching -2 from the left, we're going to find out what that sign value is. So as we're approaching -2, and we've just determined that that is definitely an asymptote, we want to know what happens. Is the graph going to go up, or is the graph going to go down, never reaching -2, but infinitely up or down? And that's what we're concerned with. So let's find out. So if we take a value, any other value less than -2, so the next whole number, -3, sorry, not whole number, but the next number would be -3 or value, we can insert that into our formula, and we can say 1 divided by -3 plus 2 is going to give us -1. Do not be confused. Say, oh, well, we have -1, -1, we're good. All we're concerned with is that we end up with a negative value at this point. So we know that the graph, no matter where it starts over here, is going to end up traveling closer and closer to -2, but infinitely closer to -2. That means that we have a negative infinity. For the other limit, as we're approaching -2 from the right side, we do actually end up with a value of -1. So it does not continue on infinitely up or down. It's not a negative or a positive infinity. This is in fact just a number -1 that we end up with. So for that, we would say that negative infinity is not equal to -1, and therefore we do not have a limit. So we'd say that this does not exist. All right. Well, I hope that helps. Thanks for watching.